Force is a fundamental concept in physics that describes the interaction between objects that result in the acceleration of one object by another. Everywhere we look, forces are at play, shaping the world around us in ways both seen and unseen. From the gentle pull of gravity keeping our feet on the ground to the flicker of light bulbs powered by electromagnetic fields, forces surround us at every turn. In the vast expanse of our universe, four mighty forces reign supreme: gravity, the cosmic embrace that draws matter together, the fundamental force of attraction that exists between all objects with mass or energy. It is described by Isaac Newton's law of universal gravitation and Albert Einstein's theory of general relativity. The significance of gravity is that it is the cosmic force that shapes the universe. Newton showed how objects attract each other based on mass and distance. Einstein revealed gravity as the bending of space-time by massive objects. It's the ultimate cosmic dance, you see, guiding the motion of stars and planets. It shapes the structure of the universe from the formation of galaxies to the motion of celestial bodies, governing phenomena such as the orbit of planets around stars and the falling of objects on the Earth. One example of gravity is the gravitational force between the Earth and the Moon, which causes ocean tides, and the gravitational pull of the Sun, keeping planets in orbit around it. Picture this. This is a celestial tug of war. Earth and the Moon are like best friends, holding on to each other, causing the ocean to slosh back and forth, creating tides. Meanwhile, the Sun acts like a big brother, keeping the planets in line with its strong gravitational force, making them go round and round in orbit. On a small scale, the impact of gravity keeps our feet firmly planted on the ground and allows objects to have weight. On a large scale, it determines the structure and evolution of the cosmos, influencing the formation of stars and galaxies. Without gravity, celestial bodies would not be able to orbit each other, and the objects would not have weight. Without gravity, planets would not stay in orbit around the sun, and life on Earth would not be possible as we know it. Electromagnetism, the force behind light and chemistry. It is one of the four fundamental forces of nature, encompassing both electric and magnetic interactions. It is responsible for the interaction between electrically charged particles. It is mediated by the exchange of photons, which act as force carriers between charged particles, repelling like charges and attracting opposite charges, with the force inversely proportional to the square of the distance between them. Electromagnetic force governs a wide range of phenomena, from the interaction and repulsion of charged particles to the behavior of electromagnetic waves such as light. It underpins countless processes in everyday life, from the functioning of electronic devices to transmission of signals and telecommunications. What's the significance of electromagnetic force? It holds atoms and molecules together, governs chemical reactions, and enables the transmission of light and other electromagnetic waves. One example of electromagnetic force is in magnets. The electromagnetic force in magnets originates from the alignment of atomic magnetic fields, which certain materials create a net magnetic field. When electrons move within atoms or through conductors, they generate magnetic fields, contributing to the overall magnetism. This alignment forms magnetic domains, which when organized create a macroscopic magnetic field. Magnetic fields are represented by field lines indicating the direction and strength of the magnetic force. Like poles repel, the opposite poles attract due to the interaction of magnetic fields. On a small scale, the electromagnetic force governs the behavior of atoms and molecules, influencing everything from chemical bonding to the operation of electronic devices. On a large scale, it drives processes such as star formation and stellar evolution. Without the electromagnetic force, atoms would not bond to form molecules, and there would be no chemical reactions. Life as we know it, with its myriad biochemical processes, would not exist without electromagnetic force. Fluidic force encompasses both buoyancy and air resistance, also known as drag. This name merges fluidic to encompass both air and water. Buoyancy is the upward force exerted by a fluid on an object immersed in it, while air resistance is the force exerted by air molecules on objects moving through the air. The significance of the fluidic force of buoyancy enables objects to float or rise in fluids, while air resistance opposes the motion of objects through the air. One example I have here is buoyancy, which allows ships to float on water. The force arises from pressure differences within the fluid caused by gravity. When an object displaces fluid, it experiences an upward force equal to the weight of the displaced fluid, counteracting its own weight and enabling flotation. On the other hand, air resistance is the force that opposes the motion of an airplane as it moves through the air. It's caused by collisions between the airplane and air molecules. Drag increases with the speed and is influenced by the shape, surface texture, altitude, and air density. The impact of fluidic forces on a small scale are that fluidic forces affect the behavior of objects moving through fluids, influencing transportation, sports, and engineering design. On a large scale, they shape weather patterns, ocean currents, and atmospheric circulation. Without fluidic forces, objects would sink in fluids, affecting marine navigation, water transport, and recreational activities like swimming. Without air resistance, objects would move through the air with no opposition, leading to different flight dynamics and potential for faster speed. The last example of forces in our nature is nuclear force, acting within atomic nuclei to bind protons and neutrons together. It is described by quantum chromodynamics. The significance of nuclear force is that it is responsible for the stability of atomic nuclei and plays a crucial role in nuclear reactions such as fission and fusion. An example that I have here is of nuclear fusion, which occurs when atomic nuclei combine, releasing vast energy. This nuclear fusion powers stars, including our sun. This process is fueled by the strong nuclear force, which binds protons and neutrons together in atomic nuclei. In fusion, hydrogen nuclei merge to form helium, emitting energy in the form of light and heat. This process sustains the luminosity and warmth of stars and holds promise for clean energy production on Earth. The impact of nuclear force on a small scale is that the nuclear force governs the behavior of atomic nuclei, influencing the stability and decay of radioactive isotopes. On a large scale, it powers stars, drives stellar nucleosynthesis, and drives the evolution of galaxies. Without the nuclear force, atomic nuclei would not hold together and stars would not shine. The absence of nuclear fission would alter the energy production and lifespan of stars, affecting the distribution of elements in the universe. To conclude, these four forces, gravity, electromagnetic force, fluidic force, and nuclear force, unveil nature's might, shaping the structure and dynamics of the universe at all scales, from the microscopic realm of particles to the vast expanse of space. Their presence or absence has profound implications for the functioning of the natural world, influencing phenomena ranging from the behavior of subatomic particles to the formation of galaxies. Each force reveals nature's extraordinary complexity and power, shaping the observable and the fundamental processes that govern its behavior. So you see here, everywhere we look, forces are at play, shaping the world around us in ways both seen and unseen.